Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is set mismatch. So let's go to LeetCode. There you go. You have a set of integers called S, which originally contains all the numbers from 1 to n. Unfortunately, due to some error, one of the numbers in S got duplicated to another number in the set, which results in repetition of one number and the loss of another number, because one number was supposed to be a unique set with all the numbers, but then one number overrode the another one. So one number is like repeated, it's a duplicate, and then there is another number that it override is missing. You are given an integer array nums representing the data status of this set after the error. Find the number that occurs twice and the number that is missing. Return them in this form, basically the array form. So here in the first example that you can see, I'll just switch the view. So in this example, you can see this is the number array that we have, and here this contains n integers. So basically from 1 to n, 1 to n, in this case n is actually 4. So in original array we were supposed to see 1, 2, 3 and 4, and that could have been in this order, there could have been another order, like doesn't matter, it's just like it's a set we are talking about. Although it's given as an array, we are talking about the set. Now if you see in the array that's given to us, this 2 is repeated. So 2 has overwritten another number that was supposed to be there, which is 3 in this case. So we need to return the number that occurred twice, 2 and 3 as an answer. Okay, 3 as an answer. Now what would be the brute force way of solving this? So the brute force way of solving this could be, how about, since I know that in my array the numbers are going to be in this range from 1 to n. Okay, in this range where n is you can say n is the length of nums. In this range I'm going to see these numbers. So if I was supposed to see all the numbers in here, then that would be like in the original scenario. But in this case I will see that there is one number that is repeating, and at the same time I will see a number that is missing. So I could just have two variables in you can say like repeat and missing. These two variables, you can just assign them -1 right now, and then what you will do is, for I in this range right here from 1 to n, given that we are visiting from n to, you can say in this for loop like n plus 1, because it excludes the last index. So it will go from 1 to n plus 1. Then I want to check, I will go through all my numbers, in nums, I will check if this num is equals to I. That means I'm seeing this number, but I will check if this repeat, I can say I can even say found or repeat or missing. Maybe I can have another variable called, let's say, found is, let's say I can say found is initially maybe not here, I can just have found equals to false, but here I will check if found is already true. If found, that means this number is repeating. So I will mention this as repeat equals to this number, that is I. Else I will basically, in this case I will say this number is missing. So missing is equals to I, but at the same place right here, I will have another else case where I will just I guess there I am doing nothing other than, otherwise I will just say repeat is I. Okay, yeah, like I wouldn't do anything. I'm only checking for repeat if this found has already been processed. So here in else case I will just say found equals to true. Found equals to, I know it's a little messy, but what we are really doing is we are going over all the numbers in this range 1 to n plus 1. Then I'm going through all these numbers and checking if that number exists. Is I equals to num? This number exists in my nums. If it does, I will have a flag called found false. But if it does, if this flag is already true, that means this number is repeating. I have already found it earlier. So I will say this number is repeating, and I will mention it here. And there will be another number that will be missing. Okay, that will not be equal to any number inside my nums. Then I will mark this as missing. Another one more case is in this right parallel to this if statement. I will have else, that means I have found the number, and this found is also false. That means I've only seen this number once, which is valid. This is not the number that I'm going to do anything with it. So this is brute force approach, because I have two nested for loops. Here the time complexity would be big of n square, and space complexity is going to be just constant. Okay, constant. So of course this is not the best approach. What we can do now is we're gonna apply a little bit of math here, and then use a little bit of extra space, and then bring our time complexity to big of n. So we'll do just one pass through our nums. So if you might have studied, if you studied, or you might not have studied. So the sum of some range of number, like let's say we're starting numbers from 1, 2, 3, 4, 5, etc. till n. So the sum of all of these numbers, let's say I call it s. Sum of this s would be I equals to 0 to I equals to n. This is n into n plus 1 by 2. This is the formula, right? I'm sure it's really popular. You would know this, but this only holds true if these numbers do not have like any a repeated value. This is the perfect range I'm talking about. Perfect range I'm talking about. Our nums was supposed to be that, but then there is just little error. That what that error has done. Let's say if total here of this would be total of nums would be sum of all the values in nums, right? N is the length, by the way. N is the length of nums. N is the length of the nums. This was supposed to be the entire sum, right? This was supposed to be the entire sum. Now what has happened with total is this total right now is equals to this sum. I'm gonna call this as maybe s. I'll call it s. Okay, I'll just name it s. I'm gonna remove all of this extra thing from here, and I'm just gonna say this is s right now. Okay, maybe I'll write it right here. So s is equals to n into n plus 1 by 2. Now tell me, this total that I have was supposed to be this s. It's supposed to be this s, but what's happened is we have added one extra. Let's say if d is duplicate, right? We have added a duplicate, and then m is missing. So what has happened is this total was supposed to be equals to s, but what has happened with this is now in this total I have So maybe, this is the total that I have. I will just do it this way. So if this S was supposed to be my total, because that was the range I was supposed to get, but I have one repeated value, so D, and then one missing value. Okay, one missing value. So one missing value. So I will subtract this value and add the missing value. This is perfect. Okay, this is perfect. So what is it that I'm trying to get now? This total is sum, S is n, and this I can calculate. This I can calculate using the length. But what is it I'm trying to find out right now? So I have two of these missing variables that I'm trying to find, right? So I cannot find both of them from just one single linear expression, right? I cannot find that. If I'm finding that two variables, then you would remember from the linear algebra, like you'll need two equations, right? So I cannot create two equations right here. So what I'll do is I will use a set. Okay, I'll use a set, so that I'll call num set, and in this set what I'll do is I will actually, when I'm going through this nums, so I can say for num in nums, if this num in already my num set, see like what I'm going to do here. So if this is already in my num set, then that means I've already found this D. Right? I've already found this D. So if I found the D, and what I was supposed to return in my result was D and M, right? So now using this equation, I can simply calculate M as well. Okay. Otherwise, I will just add this num to basically my set. Okay. I can add this to my set. So I'll just say num set dot add. You add this num. Okay, and this is in the else case, but if I've already found this duplicate, then I can return my answer. So return what I'm returning. I've already found the duplicate, which is this number. This is the duplicate. Okay, then duplicate and the missing value. So what will be missing value? So missing would be, if you modify this equation, missing would be S minus total plus D. Okay, so what is S? S would be n into n plus 1. Okay, this by 2 minus total, which is sum of the nums plus D. Okay, that's duplicate is num. Okay, this duplicate is num. So this is what we will be returning. So let's implement our solution. We are doing just one pass. So here the time complexity of this solution would be big of n, and space complexity is also big of n, because we are using this extra space used in the set. Let's code up our solution. That was not bad, right? Was it? Anyway, like, we're just learning here. It didn't have to be the perfect video, but as long as we are discussing all the things that we have done, we're good. So as I said, I'll have num set. So I'll just call it simply a set. Then n would be length of our nums. Then I will go through all the numbers in my nums. If this num in num set, then something else, you will add numset.add this number. Okay, so this is cool. And here we were supposed to return if we found that. So number is what's missing. Then I will have n into n plus 1 by 2. I hope I didn't write n minus 1 earlier, but I think I didn't. Divided by 2. Okay, then what? Then we had minus sum, so we can just say this total is some nums. So total plus d is the duplicate num. Okay, so I guess otherwise we just return nothing, like just return this empty. I mean, I'm just like putting it. There's no need to do this. All right, so I'm gonna run this. Let's zoom out. And if our math was correct, which it was, right, then it should be accepted. Woo! Okay, I think I might have ruined the video. Okay, so time complexity is big of n, and same goes for the space complexity, because we had to find the duplicate. Unless you are allowed to modify this array, I think it would be difficult to find out the duplicate with the constant space. Unless you can modify this, you could just see the number, go to its index, return that value into negative. We have done problems like that, and then at the end of the day there will be one number, one index that would be repeated. That index will have a positive value. That's the number that was missing. That's the number that was that was repeated, and then there will be an index that will have its value negative, and that will be the number that was actually missing. Okay, actually both will have positive values because of negation twice and negation none. So those two numbers could be repeated, like one is repeating, another is not repeating, and we can find out using this formula there as well. Okay, so let's zoom out. We have already zoomed out. Let's go back to AlgoYogi. This problem solves. See you guys later in the next problem. Until then, bye bye.